Hi, Viper chemistry students. Hey, let's talk about electrons and how that relates to light, and really more specifically, the quantum theory. What is the quantum theory? Um, there have been these experiments that were done, and we've found out about the model of the atom as time has gone on. Niels Bohr, the planetary model, really doesn't hold sway anymore. It's has been revamped to include electron orbital clouds and so forth. And so as we go through here, one of the things to keep in mind is that light can exist as a particle or wave. Um, Light has a certain wavelength and frequency, much like you see here, the characteristics of light. Okay, so each different color of light has a unique frequency and a unique wavelength. So if we look at the electromagnetic spectrum and visible light, we remember Roy G. Biv. This is backwards here, but it gives a spectrum of the rainbow colors. And each color, of course, has its own frequency and wavelength. Okay? So the quantum theory. Now, the way you have to think about this is that these electrons that are in existence in electron clouds around and energy levels around the nucleus can be excited. In other words, like think about somebody who takes a piece of iron and puts it down into a hot fire, and the end of that iron begins to glow and give off light. That's what we mean by like it's absorbing energy and re-emitting light. Or think about a fireworks display. There is a point where there's some chemicals that are burning and giving off light. All right, and so think of the electrons then as in a non-excited state. They're at a ground state, but yet when they become excited, they absorb energy for some reason or another, some source of energy, and it makes them go out to different levels. So these electrons then expand out. They're not stable there, and so they fall back down to their normal ground state. When they do that, they re-emit that energy in the form of light. So it's a really cool thing. And that's why we see colors and fireworks and so forth. And yeah, that's the idea. So these slides here kind of go through that idea as you go on through here. Um, the whole science of the colors that are emitted by elements is called spectroscopy. There's what's called an emission spectrum, and every element has a unique fingerprint color that it emits. And so let's kind of as we go through here, like here's the idea of fireworks, and you can see there are some elements listed there representing certain colors. Here's an experiment. If you guys were in class here in person, we'd probably do this experiment where you just take certain salts of like sodium, for example, and you put that in a flame and it gives off a unique color. Okay, so in a sense, then that kind of acts like a fingerprint, so to speak, of every element. Every element sort of gives off a unique color, has a unique emission spectrum. And so that's kind of what's being shown here. All right, what else? So again, the ground state and the excited state. And so where does this word quantum come in? So like basically what that means is that when electrons are excited, they will move out to higher energy levels, which is a certain quantum of energy. When they come back down, they re-emit that energy in the form of light in specific quantum amounts of energy. So that's where the word quantum comes from. All right, so as you go through your slide, that's what you'll see reference to. Study that. And if you have any questions, sure to let me know. All right. Thanks for watching.